Welcome back. We're going to take a look at the sign analysis method to help us solve quadratic inequalities. Please keep in mind that this is a lot different than solving linear inequalities or absolute value inequalities. There's really no shortcut. You want to make sure you go through the process so that you can determine where you have the appropriate regions for the solution. So starting off, just to kind of note, we see that we have the inequality symbol along with the degree 2 power of x. So that is for sure a quadratic inequality. And the first thing you want to do for yourself is set up the quadratic inequality so that it is compared to 0. So what I mean by that is we just move everything to one side. Probably easier to subtract 40 from both sides. So we have x squared minus 3x minus 40 is greater than 0. So see that comparison to 0. So that's going to be important later. I'll come back and address that, but there's a few things we have to do in order to set this up. So for the meanwhile, I'll box this just so that we know that we're coming back to. So before we can address the inequality, what we have to do is solve the related equation. So when I mention the related equation, what I'm referring to is if you took the inequality, x squared minus 3x minus 40, and instead of using the inequality symbol, you use an equal sign in place of the inequality symbol, still being compared to 0, then what you have is a quadratic equation for which you can solve. So there's a lot of different ways we can solve this quadratic equation. I prefer always trying to start with factoring if it looks fast for me. But we could also pull out a quadratic formula if we're having issues, or even completing the square. So the main idea is to find the roots or the zeros of this related equation, because those are what we call the boundary points. So let's do that. I see that I have a quadratic function in the form of ax squared plus bx plus c. So what I like to do is I take the a times c method. So the a times c, 1 times negative 40. We're finding factors of negative 40 that add up to b, so that's negative 3. And so the two winning factors that would happen, we should have 8 times 5. And if I need to have a negative middle term or linear term, we should have a negative on the 8. So those are the two nice chosen factors. Because the leading coefficient is a 1, we can go directly and factor this right away. There's no extra step needed. So those are kind of the quicker factorizations. The only way to make a 1x squared is x times x. But if you were to have a 2 or a 3 or a 6 or a 12, you'd have to do a little bit more to figure out what those two leading factors were in the, or terms in the binomial. So we'll get to that in a little bit. So I do have x times x gets x squared, and then what I can do for myself is choose the winning factors, write one of them in each of the binomials, and we still have ourselves equal to 0. So now we have two factors being multiplied. We'll set each one equal to 0. And I know you could probably do this mentally, but just in case, sometimes the factors are a little more complicated. So just so that you know the process, we should get x equals positive 8 or x equals negative 5. So what we have for ourselves right now, we have our boundary points. In other words, it's the zeros of your quadratic function. So what we're going to do now, this is where the sign analysis really comes into play. We're going to take these boundary points and we're going to plot them on a number line. So I'll draw myself a number line. And when I'm looking at x equals 8 or x equals -5, I'm really interested in plotting them in relation to each other. So what I see, I'm going to see the -5 is a little to the left of the 8. And you don't have to draw them to scale. You don't really have to do tick marks with zeros everywhere and make it too pretty. We just want the overall idea. You can if you want, it makes it nicer, but yeah, we'll work with what we have. So after this, what these boundary points do is they set the number line, or they separate the number line up into 3 different regions. We have the region before -5. We also have the region in between -5 and 8. And so maybe if you want to see that, just so that we can visualize this. So the region before -5, the region in between -5 and 8, and the region after the 8 to the right. So 3 different regions for the number line for which you would be choosing the appropriate region to match the inequality. But what the sign analysis method does, it allows us to analyze the signs a little bit nicer. What we're going to do at this point is take our factors, the x minus 8 and the x plus 5, and we're going to write them x minus 8, x plus 5, to the left of your number line or to the right. Just don't intrude on any of the regions of x. And this will give us a little bit more subdivision if we separate everything. We will now have 1, 2, 3, 4, 5, 6 different regions for which we're testing signs for which we can analyze, hence sign analysis method. So let's do that. What I mean by testing signs or testing numbers, we're going to pick a test number in each of the regions. So for instance, if I'm looking at the region from -infinity to -5, I'm going to pick a test point. And you can write it in there, but sometimes that gets confusing. Like what comes, maybe -6 is right after -5 or -10. I don't like to write them in because it gets confusing when you're trying to figure out the solutions. Sometimes you mistake the test point as the boundary point. So instead I'll color code and I'll kind of write my thoughts below. So if I'm testing, and I'm going to test x equals -6, what I would do is plug -6 into each of the factors. And what I'm concerned about, and I'll do that for us. So let's do that. So we have x minus 8. So we would have -6 minus 8. That's going to give us, we don't really care what the number value is. We just care if it's positive or negative. So we should get a negative number. So all I'm doing is writing a negative sign. Well, what you want to do is you chart this sign according to where it's located in the region. So we have the test region before the -5, and then the appropriate factor we plugged it into, we got a negative number, so we will draw a negative sign. We'll do the same thing with the x plus 5. We're going to plug in -6 plus 5. And again, yeah, you can calculate it, but all we care about is that we are going to get a negative number. It's -1, but all we care about is there is a sign in that region that it applies to. So we'll do the same thing. Let's take a look at in between -5 and 8. We will test as well. I always like when I have a choice between a positive integer and a negative integer, I always like to choose 0. It's a lot faster. So now again, when I plug 0 into both of these factors, you can write it down just so that we see it for purposes of the notes. So what do we have? 0 minus 8, which gives us a negative number. So here again, I'm charting the sign. And 0 plus 5, which gives us a positive number. So here I would draw a positive sign in that area. Okay, so one more. Let's take a look and let's test out a number in the region 8 to infinity. We're going to test out x equals 9, x equals 10, whatever you like. But again, if I plug that test number into the two factors, what I'm looking at, I will have 10 minus 8, which gives me a positive sign. So I'll chart that right away. And I'll also have 10 plus 5, which gives me positive 15, but I only care about it being positive. So this is the purpose of the sign analysis method. We want to figure out a sign for each of the regions that we have subdivided the number line up into. Now, all of this work on the bottom, you are not required to show this. Sometimes I just do this for purpose of explanation. But the idea behind the sign analysis method is that they really want you to be able to do this quickly and mentally. So if you can do that, it does go pretty fast. But again, if you get nervous on exams, what you can do is you always could write things out just in case you're afraid you might make a minor error. So I'll show you either way, but I prefer, usually we get faster, we ignore the extra work where we're testing the points and writing all the tests down. So we have a bunch of signs everywhere. The next thing we want to do, here's where the analysis comes in. Think about what was happening with your two factors. You had x minus 8 being multiplied by x plus 5. So if we are actually multiplying the factors, it would make sense that we would multiply the two signs vertically. So x minus 8 times x plus 5, or negative times negative, would give us a positive region. And if we say negative times positive, we're going to get ourselves a negative region. And positive times positive, just so that you see this, that should also lead us to have a positive region. So we have just analyzed the signs according to our quadratic function and inequality. So now, after we have this drawn in, what we're really interested in is actually deciding, well, should we be picking the positive region or the negative regions? And remember how I told you to circle the quadratic inequality, rewritten so that all terms are on one side and zeros on the other? Well, this part right here, the comparison to 0, in other words, if you're saying it out loud, you're saying greater than 0. And when we talk about something greater than 0, we're actually asking ourselves, where do we have a positive region? And so this is the purpose of the sign analysis method. We can go straight to our sign chart or our sign graph, and we can see right away, oh yeah, it's a positive region from negative infinity to negative 5. And it's also a positive region from 8 to infinity. So right away, we can use our sign analysis to address the solution. And so let's write that solution. And usually interval notation is popular. So our solution is negative infinity to negative 5. And then we did not have a greater than or equal to, so everything is parentheses. We do have a jump, so we're going to start up again after we write the union symbol from 8 until infinity. And so at this point, we have now solved our quadratic inequality using the sign analysis method. So if you're taking time to kind of absorb all of this, at first it does seem like a lot of steps, but once you do get the hang of it, it goes a lot faster. Plus, I do want to show you what's really, really cool about the sign analysis method is it actually solves 2 problems for the price of 1. So just a little bit of a side note. And it also kind of helps you figure out what's happening with the graph, but I'll get to that in a second. I'll have a kind of a what if. What if your original inequality had the same terms, but the inequality symbol was reversed. Well, we can still incorporate the sign analysis method. I'm still writing this in standard form so that we're comparing it to 0. So that comparison to 0, if we're going to really interpret this, this is saying less than 0. And when we're asking ourselves, what do we mean when we talk about something less than 0, we're actually referring to where do we have the negative region. So if you were to solve or asked to solve this type of inequality right away without doing any extra work after you've already made the sign chart, you can interpret what the solution is, because all you have to do is go back and figure out where is the regions that are marked with a negative sign. So that solution, if I were writing it in interval notation, we would go from -5 to +8. So 2 problems for the price of 1, no extra work needed other than creating the sign analysis chart. And just kind of want to also point out one other thing. What's happening when you make this sign analysis chart, you're really interpreting what's happening to the function in those regions of X. So what we're looking at when we see a positive, see if I can highlight it a little bit. Let's see. Yeah, I'll just point to it. So when we see positives, what they're trying to tell us is that the graph of that quadratic function is above the x-axis for those values of X. So if we're kind of looking at the quadratic function, we already know that we have a positive leading coefficient. We do know that it is facing upwards. We actually kind of have a rough sketch of what our graph would be. So maybe I'll draw that in orange. So in the yellow regions, you end up having a part of the parabolas that are above the x-axis. And when you're talking about negative regions, you're looking at the part of the parabola that's below the x-axis. So you actually have yourself a nice little rough sketch of what your function could look like. And we're pretty clear, we do understand parabolas only have a facing upward U shape or a facing downward U shape, but this comes in real handy when we actually look at the section 3.7, we start talking about polynomials. So just want to kind of, plant the seed in your mind, and so you can kind of think ahead. We will be recycling the sign analysis method over and over again, so it's really to your benefit to try to learn it now. So hope this helps. See you for the next example.